let's start. Let me just record this one. So need to do this one. All right. First of all, welcome. Okay, for start, just to confirm that it's me. All right, hello guys. So welcome, and I'm very happy to meet you all in this new semester. I will now stop my video just to make sure that I have a stable connection because I share this internet connection with my daughter. So in this semester, we will discuss about OOP, Object-Oriented Programming. I'm sure you heard about OOP before, okay? But in your current understanding, what do you think is OOP? Object-Oriented Programming. Anyone? Any thoughts?
Programming that oriented to an object, sir.
You're just switching the order of the words. What is, I mean, like, what does it mean to program using object?
Maybe it works by the interaction of object.
True. And any other thoughts? Okay, put it this way. What we've done previously in C#, in Python, we actually already do OOP. Okay, but we don't really know that we are using OOP. It's like, put it this way. When we drive a car without knowing how the car actually works. We don't care, right? What we know is that as long as we put enough gasoline inside it and let's say the battery is on, it should be fine. Okay, we can use the car, okay, we can drive the car, but without knowing how it works. That's fine. Now, in this OOP, it's like the same. We have used OOP like in last semester. We use it to create programs, fantastic, but we don't really know how it actually works. I'm not trying to discuss how we make Visual Studio. I'm trying to discuss how OOP works. In a sense, therefore, we want to build our own object-oriented programming. Okay, previously we simply use objects that is provided by the Visual Studio or Python. Now, in this unit, we will talk what if we want to create our own objects. Okay. Now, the learning outcome is actually still in Indonesian because this is taken from the curriculum. So basically, we're trying to analyze problems and make them like into a smaller chunk so it is more manageable. And having said that, we try to use that, we try to design solution based on chunks of smaller problems instead of big. And that solution, the smaller chunks, we try to create objects that we can use to solve that problem. All right. Now, upon completing this course, we expect students to be able to analyze and design based on objects. Okay, what is object? We will talk about it later. First, let's talk about lesson plan. Similar to Alpro, similar to the algorithm and programming last week, in this unit, we will have 2 meetings per week. That means 6 hours in total for a week. In every meeting, we usually arrange, normally, arrange the first meeting like this Monday to be like conceptual. We show you how it works. And then the second one, we will focus on exercise. Okay, we will focus on exercise. And since there are only like 3 of you, I can focus to understand how you progress individually. Okay, and again, as usual, please let me know if you have any problems or difficulties in this unit as soon as possible. As soon as you have problems that you cannot solve by yourself, you have tried Google, you have to try to discuss with your friend, but you can't understand it yet, then let me know, all right, as soon as possible. Now, we still use Visual Studio 2017 or 2019 from last semester. So let's just use that installation. So no new software to be installed for this unit. And as usual, I put all slides on ULS. You will need your usual Ubaya account. The ULS is currently just recently having an update. Hopefully it works better than the previous one. Now, marking. In this unit, we will have practice work. That will be like whatever we like assignment. You don't really have like a separate task. Basically, what we discussed on Thursday, once you finish that one, then you can get the 20%. Of course, we will divide that 20% throughout the whole semesters, not just one. So the practice work is basically small quizzes. And the 30% quiz is like the quiz with the other classes too. And the midterm exam is the UPS and the UAS for the final term exam. So that's it. So as you know this one, this is how you can get an A. You need to at least have 81 to get an A. You need to have at least 73 to get an AB. But we try to make you all get an A. Aim for A. Okay, at least aim for A, so you can get an A in the end. As usual, please don't do plagiarisms, even though it's with the other classes. It doesn't matter. The complexity of codings that you need to do in the semester is higher than the previous one. Having said that, we will definitely know if you copy or even some part of it, because the possibility is really big, okay, to have 2 students having the same way of thinking, same solution, even some part of it is just not possible. So we will definitely know if you like work together or do plagiarisms. Okay, please don't do this. I really don't want to penalize any one of you with this plagiarism. Now, class rules. Okay, I will try to have a break if it's a long course. Like today, we will not have too long because this is just the first meeting. So just an introduction. But if we are going to discuss a lot more, like full 3 hours, I will not deliver it like 3 hours. I will have a break in the middle. But please don't do other thing other than OOP. I know it's hard when you do school from home. There will be lots of distractions. You might not be alone in your room. There will be other people and so on and so forth, right? But try to focus on the OOP so that you can get the best of it. All right, let me know if you have any problem with your internet connection, laptop, and so on. As usual, I'm not really formal in this. You can just chat with me on Hangout or just email me. And let's try to make this class as fun as possible. Again, if you have any problem, let me know. And yes, you want to get an A. I want you to get an A. In fact, if you don't, I will have problem if too many of you get C. Okay, I will try to push you. I will not give you an A for free, that's for sure, but I will push you to get an A. How to do so? Ask, talk, discuss, complete the exercise, and as long as you do the small quizzes, the big quizzes, all by yourself, you understand how it works, not just, okay, it works, I don't know why, that's still a problem, okay? So that can be your checklist to understand whether you're on track or you lag behind, okay? I think that's enough for the introduction. Let's start. Now, why we need OOP? Okay, I tell you the truth. I hate OOP when I was in your seat. Okay, when I started to learn OOP, it was named Pemrograman Berorientasi Objek. Man, I hate it. Okay, it's so complicated for me. Okay, and only until I understand what it is, I was just like, all right, okay, I cannot do coding without using OOP. Okay, so because everything is in OOP is make it easier. Okay, and it's if we want to coding without OOP, it will be a lot of trouble. Why? Put it this way. One of the biggest advantage in OOP is reusability. Okay, if we create an object, which we obviously will, like what is an object first? Object can be anything, any variable, any object, any things that you use in coding is an object. That includes the variable that we create. That includes the control such as forms, text boxes, label, button. In Visual Studio, each of those are object. Okay, now put it this way. When we create a form, like in last semester, a form can create many text boxes. As you know, those text boxes behave very similar. Okay, it looks the same and it has the same property to control the text box. You can control how long it should be, how short it should be, and so on. You can control the fonts to use, the size of the fonts, the color of the fonts, and so on. And whenever you create another text box, you can do the same. Okay, that's the brilliant thing about object. Once you have the class and you have the template, you can reuse that object over and over again. And each object will behave similarly so that you don't have to create coding behind it like manually over and over again.
Sir,
Yes.
are you trying to share your
Oh,
screen?
I didn't?
It's not, yeah.
Gosh, sorry, guys.
It's okay. We have the slide, right, sir? But if you're
Yeah,
trying to explain, I can't understand.
I know. That will be, sorry, my bad.
It's okay,
Can you,
sir.
can you see my screen now?
Yes, now we can.
Okay, cool. Right. Well, sorry about that. Right, let's start. Let's continue. So now, today we will learn also how we can create object and classes and object. Okay. Now, as you guys mentioned before, Catherine and Kenneth, you have said that programming is where the program works by interaction of objects. Yes. So for example, in here, a car works by the interaction of all parts. So object, a car, is an object. But that one object also have many objects inside it. Okay, it has wheels, it has seats, it has body, and so on and so forth. Now, every car will have a similar thing. Okay, right? So there are different cars, but most of them have a similar properties. Okay, every car must have 4 wheels. Okay, normally, and they have seats, and they have brakes, they have pedals to accelerate, and so on. They will have doors, of course, obviously, and so on and so forth. Okay, so that's each of them are parts of the car object. Okay, now hang on. Sorry. Now, in OOP, we use OOP to encapsulate things. Okay, encapsulate means we wrap. It's like wrapping, and let's call, and it becomes a new object. So instead of understanding each of these components, we can just wrap all of this inside the car and call it car. And therefore, you don't need to know anymore those who use the car, those who use the car, who drive the car, don't need to know about each of these components. I don't even know if there exists. I don't care. I don't need to know. Once it's wrapped as a car, I can simply use the car. I can simply use the car, and therefore I don't need to know about what component is inside the car. And therefore, it is easier to be understood, it is easier to maintain, and it is easier to reuse. Okay, now imagine if a car is created of one object only. Okay, if you have a problem with one part, then you will have to fix the whole car. You cannot just unplug the car and then fix the car, fix the tire by itself. If you imagine, let's say this way. Do you know there's a like Mac Mini, not Mac Mini, what's it? There's a screen that also contains the CPU behind it. So it's like one of the Mac, what's called that? One of the Mac product. So it's they wrap it as a one product. So it's a monitor, and there's a CPU behind it and everything else. So you don't need a separate CPU. Okay, that's good, that's nice. But if there's a problem, then you will need to fix like the whole thing. You cannot just, if you have a broken monitor, there's a dead pixel, you cannot just swap the monitor, because the monitor, the CPU is right behind the CPU is right behind the screen. So if you have to fix, you have to fix everything. Okay, that is hard to maintain. With OOP, because everything is in parts, is separated by itself, if there's a problem with one coding, then you can just fix the coding. And when it's fixed, then every coding that is using that object will have the same update, will get fixed automatically, right? As I mentioned before, we actually have used OOP concept in RPro. Okay, so you really going to be familiar with the things, some of the things that we are going to talk in this unit. Okay, the thing, as I mentioned, in RPro, we use existing class. Okay, we use existing object that is provided by Visual Studio, and in this OOP, we will learn how we can create our own class and then how we can use them. Now, in other words, in RPro, you were trained as a programmer. Okay, as a programmer. In here, you will be trained as an analyst. You will need to analyze what parts is needed and how we should combine these parts, how these parts should interact with each other, and so on. Okay, by the end of this course, you will be able to write program as a solution for a certain problem as yourself. Well, I'm not saying that with last semester you can't, but in here you can do better. All right. Now, I spoke before about class and object. Formally, class is a blueprint that is used to create a certain object, and an object is instantiation or creation of a certain class. For example, class can be a car or a racing car in here. This is class of a racing car. Okay, this is the blueprint. Now, an object is the racing car itself. An object is the racing car itself. From the same class, we can have many cars. Okay. Oh, of course, this will have the same different colors than this one. This may have different type of engine, but still they are coming from the same blueprint, from the same what's called class, from the same class. Okay, the features are exactly the same. It has wheels, it has steering wheels, it has mirrors, it has and whatever, the body and so on. Okay, but you can tell they have the same or at least similar features, and therefore they are from the same class. Okay, another example, for example, class can be human. Class can be human. The objects that comes from human can be Jimmy, can be Agis, Kathleen, Kenneth, and so on. Make sense? So class is the type, object is the instantiation. For example, put it simply, let me open my Visual Studio. So Studio, let me just create a new project, just an empty project. Let me just put it wherever, it doesn't matter. Okay, things like integer. Integer is also a class. Okay, if you want to put it in a C# example, integer is a class. Float, text, even text box is a class. So integer is a class, and if I say it in here, let's say salary, A, B, C, and so on and so forth. Okay, integer is the class, salary, A, C are objects of class integer. Make sense? Okay. Now, another example in here, as I mentioned, not just integer. Everything in Visual Studio is based on objects. So these are the class. As I mentioned in my previous example, I use a simpler object, integer. We can also create a class. We can also create object based on class like label. We can create a new label. So this is the class. You can say data type if you want. And these are the objects. This label info is object of class label. Okay, and this is instantiating. It means like it actually creating the objects so that it is ready to use. This complex object instead of integer we can directly use. Okay, we don't have to instantiate it, but a complex object other than the basic objects such as integer, float, string, and so on, we need to instantiate it. Instantiating it means we actually create an object so it is ready to use. What happens if I create label? Let's say, what happened if in here I said I want to create, let's say, label, my label. Okay. When we do this, we actually just saying, okay, I want an object called my label. My label type is a label. That's it. I cannot use it just yet because I have not created this one. I simply just like book a variable name, my label. So it cannot be used by other object. So this my label is name of an object. But that's it. I have not created this one. If I want to create this one, then I need to say my label equals to new label. Simple. Okay. Or we can do same my other label equal to new label. Okay. It's just different way of expressing the statement. Okay. This is indirect instantiation. This is direct instantiation. It means when we create when we declare the object, we immediately instantiate it. Okay, that's the difference between here and here. Which one better? It doesn't matter. It's based on your preference and your need. All right. Later we will know that some require immediate instantiation and some require deferred or to be instantiated later. Okay. Now, objects in design view. For example, with the C# GUI, graphical user interface, it allows us to create object using the design view, where we can just drag, click and drag drop to create objects and to modify its property. Okay, but in the end, it's still an object. Everything you see in here is an object. So the whole thing, the container is an object of class form. The object of a text box is from class text box, and so on and so forth. Okay, so but I can't see the declaration, Jimmy. Where's the declaration? Where's the instantiation? Do they have this one? Yes, they do. I'll show you. So for example, in my form, let's say I create a button and a text box. Okay, let's say I create this one. Right? Let's save this one. Go here. Let me just do this one. Now, I can just go here. Let's say this is button one click event. I do right click and then go to definition. Oh, sorry, this is the definition. The program should be here. Here. Transform. I want to go to the, there you go. If you go to the form1 designer.cs, which is here, but anyway, this is the declaration. Private system Windows form, this is the type, this is the class name, and this is the object name, button 1. Okay, and this is the text box class, this is the text box object name, text box 1. Okay, so everything in what you see in here, okay, is object. The form itself is an object. This one is an object. This one is an object. Jimmy, does it mean that we can create this object on the run? I mean, when we run the application, can we suddenly pop or show a new, let's say, text box? Yes, yes, we can. We can create a new text box to appear when we run the application. Okay, because simply they are just a variable, just like variable. Yes, they have a more complex structure, but they still a variable. You can say object as a variable. Okay. Now, these are features of object-oriented, or people call it OOP principles. First, encapsulation, hiding the object's internal implementation and preserve data integrity. What does it mean, encapsulation? It means that once you have created a class, then people can just use features of that class without knowing details of that class. So put it this way, it's like creating functions and methods. If you remember from last semester, put it this way. I want to create public integer, let's say square, integer square. Count square, for example, or just square. Square integer number. Square. All right. Why? Okay. Return number times number. Let's say I have this simple method named square. This square encapsulates this. This square method encapsulates this process. So once I encapsulate this as a user, okay, I don't really need to know what's inside this. I don't care. I don't need to know. As long as I know, okay, if I want to get a square of a number, I simply can call this method square and supply it with a number, then I will get the square of this number. Make sense? Let's say integer a equals to 10. Okay, and I want to say result equals to square a. I can just say, and I put it in the message box, show result dot text. Sorry, two strings. Now, as you can see here, once I encapsulated this process, literally, the user, the developer, no longer needs to know what's going on inside this one. Okay, that is called encapsulating. So when I want to create a square, I simply can just call square, provide it with the a number, and then I will get the results. I don't care what the square method do with this number. I don't need to know. Okay, that's encapsulation. Now, this is a method. A method can only encapsulate what's it called? Statements like this. a square can encapsulate data and also data or properties and also methods. So you can consider class is like more advanced than a method, because a class can have method and also properties or data member. Okay, and that helps. Again, that is encapsulation. And that is also a description on abstraction. Abstraction is we try to reduce complexity by hiding irrelevant details. As I mentioned before, once we encapsulate it, we don't need to know what's inside. Users don't need to know what's inside. I don't care, right? Just like we don't care what happened if we, let's say, turn on the car. Surely there many things happen, okay, under the hood. Surely many things happen, but we don't need to know that, okay? We just need to turn the key and it's on. That's it, as simple as that. And that goes the same for programming too. All right. Now, okay, hang on. Inheritance. I will not talk much about inheritance and polymorphism now because we will talk about this one later in this semester. But basically like this. Inheritance allow you to, you know what inherit means? Before I move on, anyone? What is inherit? Agis, what is inherit?
I have no clue, sir.
So you should ask. You should tell me. All right, Kathleen, Kenneth, what is inheritance?
In Indonesian is menurunkan, like
Yes.
dari bapak ke anaknya.
Good, good. Itu warisan. Okay, menurunkan, mewarisi. Okay, inheritance. So say for a human, let's say I inherit my father's eyes. It means my eyes looks like my father. In OOP principle, inheritance means the children inherit whatever the parent have. So if the parent have a certain property, the children will have the same property. Okay, that is inheritance. Polymorphisms means it can transform into different objects. It can transform into different objects. Okay, that is as much as I want you to know, because we will discuss about that in details later on. For now, let's just focus on features in encapsulation and abstraction. Now, as I mentioned before, when we encapsulate, we actually wrap like data and methods as one unit. And that is the difference between methods. Methods simply encapsulate statements, like I shown you before with methods square. Okay, but a class can encapsulate not just statements into methods, but also data. Next, we can also protect the data from being accessed from outside. And this is sometimes necessary, especially when we should not change that data. Okay, when we should not change that data. For example, I'll tell you the example later. We will have that example. The data in the class is called property data member, and we can access that using property. Okay, so the symbol of property in Visual Studio is this wrench tool. Okay, this tool, this is symbol of property in Visual Studio. Okay, now look at in here. Okay, there are two properties in this picture. They are name, left, and location. And the symbol in here is the symbol of the property, and in here, you can see get means, I can how to get this one. It's easy. Let's just use this one. My label dot. This is actually the what's called in IntelliSense, I think. Okay, these are properties. Okay, get set means you can get the value or you can set the value. Okay, that is the meaning of the get and the set. You can get the value, meaning you want to know what is the top property value at the moment, or you can change or you can update the top value using set. That's called get and set. Integer is the data type of this property. So this top property is integer. Okay. So this is the explanation. Now, example of getting a value from a certain property. So if we say integer left pos equal to label info dot left, meaning we get this left property value and we put it into variable left pos. But if we put statement like this, label info dot left equal to 100 meaning we set the property left with 100. That is set. Okay. Now, check your understanding. Anyone, which code will produce an error, A, B, or C? Okay. So is it integer label? So we focus in here. We focus on property name right. Okay. Look at in here. Which one will produce error? Integer
B.
label right. Sorry.
It's B.
B. Why?
Yeah, because it can be set. Yeah,
Yes.
I think.
Correct. As you can see here, this property only have get method. There is no set. Meanings we can only get the value of this property. Okay, and statement A is getting the value, and so does statement B, although it's not shown in here. However, what will be error is obviously B, because in this one, as highlighted in here, we only have get. We cannot do set. We cannot do set. And therefore, if we try to set right with 100, it will get an error. Okay. Now, we can change the value of a property in a design view. Yes, we did that like many times before. For example, this one. These are the properties. Okay, whatever we can set in here, it means it's in the set one. We can set in here or we can set inside from the coding. It's the same. So in here, let's say we change the text. This is a button, for example. What I did is I set the property. Okay. We can change the sort, the order, whatever, it doesn't matter. Okay. Now, I don't think there's an explanation further on this one. We will talk about, I will show you a property, how we can create a class. Okay, just quickly, because I'm sure we're going to create one next on Thursday. For example, let's say I want to create a simple class. As you can see here, the form itself is a class. Okay, it's called class, this one. let's say I want to create a public class circle. Okay, that's it. I just create a class. Okay, now let's say, what is a property of a circle? Let's say have a float. Radius. Right? Let's say it has a radius and we want to call it as a private. Okay, now it means I just created a data member. This is called a data member, a data that belongs to this class. A circle has a radius. All right, a circle has a radius.
What does single means?
Single is decimal.
Okay,
Integer
thank you,
is round number. Single, double is a decimal type. Usually people use double, so let's just use double. What is the difference between single and double? Precisions and range, just like integer and big integer. Okay, so basically single and double are decimal types numbers. Okay, now let's create a property. Quit actions. Hang on, I forgot how to create property. Let's check on Google. How to quickly create, because I'm lazy, you know me. C# properties. Refactoring. Right, so basically I can just say public radius double radius get set. That's it. For now, let's just use that one. Meanings, I allow people. Private means it can only be accessed from inside this class. Okay, so having said that, just use this one. Let's focus on this class. Make it smaller. Having said that, if I create, because I already create class circle, I can create my circle, small circle, for example. I just create an object of class circle, which is this. Make sense for now? Okay. Now I want to set the small circle radius. I want to set the small circle radius. If you check here, look here. This one is small capital R, and this one is small case R. This is big case or capital R. It's different. Okay. You don't have to do like this one, but you can. This is the common way people do it. So the data member is written in small case. The property is written with camel case, like this one. So I cannot access the data member. I cannot access the data member directly because it is private. This is what I mentioned before, that we can protect the data from being accessed from outside. Okay, so because this is private, I cannot just immediately access that one. because this is my own class, I need to instantiate it. New circle. Okay. As I mentioned, I cannot just do this. Whoops. I cannot just do dot radius equals to 10. And he immediately change it. Let's say I force it like this. I can't. If we say this, circle dot radius is inaccessible due to its protection level, because the protection level is private. It can only be accessed from within this class, not outside. So what if I want to change this member? Then I have to use the related property, and this is the property. As you can see in here, I allow get and set, meaning I can do radius. This is get or set. Get or set.
Set.
Set. And I can also do integer r equals to small circle dot radius. Why? No. Sorry, the problem is data type. Sorry. Wrong case. Okay. That's it. This is get. This is set. Okay. So if I said, okay, people should not set this one, then this will be a problem. If I remove the set one in here, this will be a problem, because it says here, okay, this is read only. Why it is read only? Because we only set the property get. We don't have set for this one. Make sense about properties? So there are properties that is read only. There are properties that we can read and write. And there are data member that only that without properties. Okay, we can have that one if we want, and that's fine. It depends on the requirement. Any questions so far on properties? All right, let's move on. So this is as far as I want to explain, because we will have another in-depth explanation on creating this one. We don't really need to actually work on C# yet, but I think it's better if we can have an example on what is property instead of just understanding the concept. Now, that's property method. Get set is actually a method, but we can also create another method other than the property of get set. Okay, now let's see. These are methods for class label. Okay, it is called like with symbol box like this. This is the symbol of method in Visual Studio. And with methods, you can see in here, in front is the return value. Okay, void means this control height does not have return value. But with this one, at the end, it means it does not have a parameter. Okay, it doesn't have a parameter. Okay, this is what I explained before. If it's void, it means it does not have a return value. And if this one is empty, it does not have a parameter. Okay, now we can call that method. If we don't, if the method does not have a return value, we can just call it without any variable in front of it. Okay, let's just do something with our circle class. Let's say I put the setback in here. Let's say I want to create a public double get area. Okay, I want to create what is it? It's okay. I want to create a method. I want to create a method to get the area of a circle. Okay, I want to get a method to get an area of a circle. How to compute the area of a circle? Anyone? Come on, you all pass your elementary school, right? You should know how to count the area of a circle. Anyone?
Pi times radius the power of 2.
Good. So let's say I create double area equals to pi. I think we can get the in here math.pi, or you can just use 22 divided by 7. Radius power 2, I believe. What? Right. D F 0.0. Oh, okay. Right. Don't care. Radius. Okay. Good. Now we return area. Okay. Now I just create a method. My own method, my very own method, and inside this one, because we already have the radius in here, I don't need to put parameter. Why? Because the object already have the radius. Make sense? Now, in here, first we set the radius of my object, and then we can, let's say, message box show, let's say, radius plus what? Small circle dot get area to string. Are you comfortable reading this statement, or is it too long? Is it okay if I just write this one, or you prefer me to do this? Double, let's say, circle area equals to up to you. Which one do you prefer, or the same? So basically, in here, I call the get area. When I call the get area, I'm actually executing this one. In here, I execute pi times radius, and I get the area, and I return the area. What is the radius? Radius is based on the data member value. In here, my circle radius, I already set it to 10. Okay, and if I load this one, therefore I will get 327 something, should be. Why it's so slow? What? Where's my form? Ah, okay. There's an error. This is never assigned. Okay. Hang on. No, this is not it. There is no problem. Ah, there you go. Sorry. I'm using two screens. For some reason, this one decided to pop out on another screen. Why 0? Okay, it must have something to do with this.
Oh, sir.
Yes,
I think we should get the radius from radius that has
this one.
capital R.
Ah, no. No. This one?
Yeah.
It doesn't matter. It doesn't matter. I think what the problem in here, I think the property is wrong. Because if I do this, oh, sorry, you're actually right. Right, okay, my bad. You should go with this one, and then it will go to get this one, this radius. Okay, so yes, thank you for that. So basically, let me just close this one. That is 10 times pi, sorry, pi times 10 times 10. If we want to create another object, let's say circle, other circle, for example, I can just create a new circle. Okay, and this one is, let's say, other circle dot radius, let's say it's bigger, it's 20. Okay, this is another circle, but we can just use the same method, other circle get area. Okay, and in here we can just display it, the same circle area, right? Because in here I'm reusing this variable, but I'm computing the other circle area. The other circle radius is 20. Okay, the other circle radius is 20, and therefore the return value of this one will be 600 something instead of 300 something. Okay, this is the first one, the small circle one, and this is the other circle one. Okay, it is pi times 20 times 20, which is roughly this one. Make sense? That is, I'm just explaining a simple class with a data member, and sorry, actually we don't need this one. because this is a shortcut, if you must say. This is a shortcut to create a data member along with its property. That is why before I got it wrong. Okay, that's my bad. But this one is actually the data member, and this one is the properties. Okay, so this is how we can quickly declare the data member and the properties by itself. There's no R with small letter, but this is the same. I got it mixed up with the usual, the other format. Okay, the other format is looks like this. Okay, you do one of these, not both. You can do private. Let me just do this one. Just to show the difference. Circle 2. Okay. In here, I have private, double, radius. Okay. And then in here, instead of doing that, I create radius, the property separately. And in here, I said get return radius. Set. Okay. This is another method. So we can create the data member separately than the radius. Okay, Jimmy, why we need to know this if we can just do this? If you can do this, then do this. But this is a default, let's say, what is called? Default way to do it. Okay, but sometimes we need to do something within the get and the set. Then we need to do this instead of this. But yes, if you can, you have the option to do this, then just do this. If you don't want to do anything with the, especially the set one. What kind of thing? For example, we want to make sure that the new value should not be negatives, for example. Then we can set checking within the set property. Hang on, it's raining here, so I want to close my window first. Better. Make sense? So there are two ways. Well, actually, there are several ways to create data member and properties. This is the simplest one. This is another alternative. Okay, and that's as far as I want to show how to create data member and properties. We will have another practice about this one next meeting. And that's it. And this is basically depends on the methods. Now, let's back on the slides. You cannot see the method in design view. Where is design view? This is design view. What is this? I fixed this one. I fixed this one. Oh, I haven't. So in here, Why? It requires dictionary. Okay. Class one can be designed, but it's not. Okay, maybe I should not put in here. But basically, okay, I should not put another class in there. I will tell you how to properly create a separate class file next meeting. But what it means in design view, in here, we cannot see the methods, okay? We can only see the property of things. Like in here, this is properties, not the methods. Okay, that's what this slide means. Now, because C# has so many properties and methods, you need to learn how to use the properties and methods that are not taught in OOP class. Okay, you can Google, you can do whatever. Okay, you don't need to know how it works, but you need to know how we can use them. All right, now let's not worry about coding. For now, let's not worry about coding. Let's say we want to discuss some problems in real world, and we want to look at it from the perspective of object-oriented programming. Let's say we know OVO, that it's one of the payment apps that we can use, and open the app. Let's see if you have it. You can have OVO or whatever. You can use, what is the competitor of OVO? GoPay, OVO, GoPay, they're the same. Just look at them and see what are the OOP components that is used in that application, for example. What do you think? What is the data? What is the class? What class is there? What data is there? What method? What object? Okay, find any possibility of classes, data members, method, and object. You can use Shopee or Tokopedia if you want. For example, in here. What do you think? I don't want to open my OVO account here. So let's just discuss. Let's just discuss about this one. Each of you know OVO, right? Or GoPay or Link. They're the same. Anyone?
Yes, sir.
Okay. All right. So in this one, let's say in OVO, obviously there's a class named OVO accounts. Each OVO account will have data member and its respective properties such as name, phone number, OVO ID, PIN, OVO cash, OVO points, everything else. Those are the data members and properties of OVO accounts. You can see them and you can change them. Some you can change, some you can't. Like OVO ID, you can't change it. Okay, but PIN, phone number, I don't think you can change your phone number. You can change your name, I think, maybe. And the OVO cash can change too if you put some money in it. Okay, so obviously those data member have the get and set properties. For OVO ID, maybe you only have the get properties, not set. Okay. Now, methods. What can OVO account do? What can an OVO account do? It can register, it can log in, it can log out, it can top up, it can transfer, it can get history, and so on and so forth. Those are methods. So what are the objects? If I have account, then that is an object of my OVO account. Jimmy's OVO account is an object of class OVO account. Elisa account, Maya account, Joko account, and all and everything else, each of those is an OFO account. So do you understand the difference between class, data members, methods, and objects? Good? Easy. Another class, another possible class is promo or deals. Each promo will have title, description, location, period, term and condition, pictures, and everything else. In here, for each promo, we can do actions such as buy, redeem, search, and everything else. These are methods. What are the objects? Well, each deal is the object, such as there's a buy one, get two deals. There's a 40% cash promo deals. There's a free whatever deals. Okay, those are the objects. So it's the promo instances. Those are the objects. There can also be the merchant and tenants object. Each merchant have name, address, description, pictures, and everything else. For each tenant, they can register, login, log out, search, and everything else. Who are the objects? The objects can be the chat time, Carl's Jr., McDonald's, Burger King, whatever that can accept OVO. Those are the tenants, right? Tenants can do everything in the methods that is allowed for them, and so on. Make sense? So this is how we can try to understand the system or a real world problem or a real world situation with OOP. Obviously, it may looks different behind the hood because I personally don't know what kind of class they have, but we can analyze based on our experience that, oh, okay, they will have this kind of objects, and these objects will have these data members, and because these objects can do this, this, and that, it means these are the methods, and I can also analyze what is the possible objects of that one. Make sense? Now, how we can design this one? If for programming, we design a programming using flowchart, as we discussed last semester, for OOP, we can also design the OOP relationship using something called UML. Basically, there are many class diagrams, but UML is one of the most frequently used class diagram. So in how it looks like. So for example, this is an example of a complete UML class diagram. Let's find something easy. For example, a book. This is called entity books. Well, we can just call it a class book. This is class name books. And these are the data member. A book have book ID, type integer, book title, string, author, string, ISBN, publisher, category, and so on. These are the data member. And in here, these are the, if you look at this one, this is actually the properties, because this is simply get and set for this one. This is the properties. I don't see any specific methods for this one. So these books only have the get and set. It doesn't have any properties. Admin the same. It doesn't have a properties. Librarian in here. This is the data member. There's a add customer. This is a method. Delete customer. This is another method, and so on. So in here, these are the properties and methods. Okay. This is an example of this one. And these lines that connecting the classes are relationship between objects. Relationship between objects. So in here, we can say librarian works in a library, for example. There's a relationship in here. Okay. Now, as I mentioned before, as reflected by the lines between objects, between classes, a class may relate to another classes. This is called relationship. Okay, but I will not talk much about that one today, but later. Now, in UML's class diagram, we design or we draw classes in this format. A box, the top one is the class name, followed with the second box, which is the data members or fields, and the last one is methods. Okay, the last one is methods. So using our discussion before for the OFO case, we have 3 classes: OFO accounts, deals, and merchants. Merchants have name, phone number, OFO ID, PIN, OFO cash, and OFO points member, and they have the following methods. Okay, deals have these members and these methods. Merchants have this name, address, description, picture, members, data members, and data methods, sorry, not data methods, methods for merchants, including register, login, logout, and search. Okay. Now, exercise. Okay, exercise. One of the famous social media apps is Instagram. Open the app. Okay. I forgot my Instagram account, but I remember I've created one, but I'm sure you do. If not, then just use other social media that you have, and then try to analyze this one. Analyze what classes is there, what are the data member, and what are the method. Okay, discuss this case with your friends, at least 2 classes. Okay, now I want you to draw. And in UML format. Okay, you can use this one, or you can choose any transportation apps like the GrabFood, GoFood, whatever. Okay, pick one. The social media, Instagram, it doesn't have to be Instagram, it can be anything. Now, how we can create a class designer? Okay, this is for next week. Okay, but for next week, try to install class designer. This is how. Okay, so next week we can start using it. All right, for now, let's just use Word with tables to create this for case number 2 and case number 3. Okay, let's have a 15-minute breaks. Let's go back on 11:45 to have a short discussion on this one. So I want each one of you to pick one case. You can choose GrabFood, GoFood, Gojek, or you can choose social media, Facebook, Instagram, what else? TikTok, whatever. Okay, I don't care. Just draw like this. Okay, in your own thoughts, and I would like to see in 15 minutes. All right, make sense?
Yes, sir.
All right.